So the first concept is the random variable. From this we are going to start. So who can tell what is random variable in layman's point of view? Who can tell? Have you heard about random variable or random? He is doing a random or random click, something related to that. Okay. Now here we have the concept here random variable. So what is that? You see the random variable is a function that associates a real number with each element in the sample space. Okay. So let us first see the thing mathematically. Okay. So what it says, random variable, or you can say R. Random variable is a function from sample space to real line R. Okay. So maybe you can say array random variable, or simply you can write small r. So small r is a function, uh, okay, from x to r. That means if we say that tossing 2 coins, okay, tossing 2 coins. Now tossing, if we toss 2 coins, then what are the outcomes you can tell? You see, that is very important. You have to
Four sets.
understand.
Four
Huh.
outcomes.
Yes, yes. So we have to understand actually how it is mapping from this. So X is your sample space. So X, I can write. So X is like, if I am writing H for head and T for tail. So first
H H
H H
H T T
H
H
T
T T
T H, correct, then T
T
T.
T.
So there are 4 possibilities. Now how to define the random variable here? So if I am taking the sewing head, sewing head is the main objective. Okay, so sewing one head, I can write one because one head is coming. Two head, I can write two. Okay, so if we are writing for this, if I write case 1, for case 1, okay, so for case 1 means we can write r, okay, from x to r, in place of r we can write 1. Okay, so when r of x to 1, that you have to find. That means when head is coming, so this is nothing but what, first case, because two head also coming. One head means not only one head, one or more also coming, at least one head, huh? So HH, HT, so TH, so this is the set. So this set, okay, is the outcome. If I want to see the second case, okay, two head, only two head, if I want to say, so it will be HH, okay. So in that case r equal to 2. In this case r equal to 1. Understand? So random variable is a function from or mapping from sample space to R. So this is the total outcome. This is the sample space. So sample space to corresponding some number. Okay. Similarly, drawing a ball or drawing, if you have a bucket of balls, red color and black color and something. So if you draw some balls, like 2 red I need, there are 10 red balls, okay, and 10 black balls, okay. 2 red, I need only 2, there are only 2, at least 2, okay. Only to at least to how to do that time, it will be probability of x here one head, huh? One head means this we have done, okay, that we have to find. So this here it is 3 and total is 4. If you see cardinality, huh, the cardinality will be 4, it's not equal to actually, the cardinality, just you can write comma for that. So cardinality of x. So it will be 3 by 4 we are getting. Now if I tell if probability x equal to 1, that means only one head. This means only one head. Understand the concept very, you have to understand concept, because it's the first concept you have to understand clearly, then only you will cope up with others. Okay, so P here it will be exactly 1 means this case and this case. So 2, the number of 2 case, so 2 times 2 by 4, so 1 by 2. So probability is 1 by 2 for this random variable. Understand, when the random variable says that only one head, then the probability of occurring of that random variable, like just for example, I am throwing some dice, I am throwing balls, okay, so randomly how it will come, so randomly how much times it will come. Okay, what is the probability of that randomness? So that is this probability which we will go through in detail. So let us move on to this slide part. Okay. Now we will go through the basic definitions and all. Okay, then we will try to figure it out things. Now, so two balls are drawn in succession without replacement. Understand the situation, because if you understand the problem statement, that means 60% part is solved. Only you have to do calculations. So two balls are drawn in succession without replacement from an urn containing 4 red balls and 3 black balls. Okay, so there are 7 balls. So out of that we have to draw 2 balls. There are 4 reds and 3 black balls. So the possible outcomes and the value y of the random variable capital Y. This is the possible outcome and the value of y. Small y we have to see, where capital Y is the number of red balls. So if we are seeing red ball, we are drawing 2 balls. So what are the options? There are 2 red ball may come. Then other option is red black, black red, or black black. So these conditions. Now if we write down the random variable, what number we will assign for this? Because we are considering capital Y, we are considering the case where the number of red balls are drawn. So 2 red balls, that's why random variable is 2 here. The value is 2 here. RB, one red ball. Okay, so 1. BR, first black, then second red. That means 1 red is coming altogether. So it is 1. Black, black, so it will be 0. Understood how we are writing random variables, how we are doing that? If it is clear, then next concept is there that we have to see. So one question we have is, stockroom clerk returns 3 safety helmets at random to 3 steel mill employees who had previously checked them. Clearly understand the problem, you have to tell the answer. Then we will discuss what will be the answer.
Hello, sir.
So, yes.
In previous question, the outcome of the black is 0.
This one, black.
Yes, sir.
This is not outcome. Actually, for black, we are assigning the real number. What real number? Our aim is that this capital Y is the number of red ball. So we are concentrated on red ball. So how many red balls are coming? So if 2 red balls are coming, so we are assigning that real number is 2. Similarly, here If two blacks are coming, so how many red are there? No red. So that's why the real number what we will assign, that means R is a random variable from X to R, yes or no? X is the sample space, so sample space to this real number R, what R we have to assign? 0. Is it clear?
Yes, sir, clear.
Okay, so then you can try to understand and try to tell the answer. So stockroom clerk returns 3 safety helmets at random to 3 steel mill employees who had previously checked them. Okay, so who are they? If Smith, Jones and Brown in that order receive one of the 3 hats, list the sample points for the possible orders of returning the helmets and find the value m of the random variable capital M. Okay, we have to find out the real number R. Okay, what we will assign that represent the number of correct matches. Correct match, you see, Smith, John, Brown, this is the order we have to match. How to do that? Simple. For Smith, if I write S, for John, if I write J, and Brown B, I will write. So first combination is S, J, B, that we can write. So if S, J, B, then it will match because first one is Smith, second one John, third one Brown, so M value will be 3. Okay, you see the same concept how we are interpreting here. If the order which we will take, returning order, okay, the returning order is like Smith, okay, Brown, John, then Smith is coming first, okay, he took also first, then one match, but Brown returning second, okay, but took third, so not matching. Similarly, John also is not matching. So one match is there, that's why one we are assigning. Similarly, if Brown, John, Smith, then one match. John, Smith, Brown, one match. But if see, if John, Brown, Smith, in this order they are returning, so there will be no match we are finding. That's why 0 we are writing, real number. So Brown, Smith, John, it will be 0. You see, the randomness or random variable, how it changes with the problem to problem. Here ordering is the important thing. So based on order, 3 people are there, the 3 matches are there. That's why the real number 3 will come. 3, 2, 1, 0. Understand? So that way you can interpret the thing. Now, if a sample space contains a finite number of possibilities, so till now what we have seen, tossing 2 coins or Smith, John, Black, Brown, sorry, those things we have seen, the ordering problem. There also we have seen, so finite number of cases, we can count it easily. 1, 2, 3, you can count the random variable, yes or no? Sorry, we can count the possibilities. Similarly, you're picking the red black ball also, you can count it. So when we will have that, means when we will have finite number of possibilities, this is very important. When we have finite number of possibilities or an unending sequence with many elements as their whole numbers, then it is called discrete sample space. Understand? Next, if a sample space contains an infinite number of possibilities, you cannot count it, or infinite possibility is equal to the number of points on line segment. Like if I tell 0 to 1, tell me how many real numbers are there. Can you tell? No, because there are infinite number of real points, real numbers in between 0 to 1. So when you have intervals, or some line segments, then that sample space where this type of possibilities are there, where your line segment or intervals are there, then it is called continuous sample space. Simple, discrete, continuous. So first we have random variable. So random variable is a function from sample space to real number R. Just think about sample space is your domain. Now domain is two type again, discrete type or continuous type. And then we will see how through problem also we'll see what is discrete type, what is continuous type, and if it is there discrete type or continuous type, then what will happen, how to write different things or how to operate all other things we will see. So the set of order pair. Now if we have a set of order pair where element x is there and the function of that element is there, okay, is a probability function or probability mass function. Here I am saying that x means like tossing only one head. So tossing of two coin and getting only one head. So that is two number of possibilities two, but total possibility will be 4. So 2 by 4 is 0.5. Now if I take x as only one head is coming, then what is the probability? 0.5. So the x and the probability, so this order pair is a probability function or called probability function, probability mass function, or it is called probability distribution of the discrete random variable x. If for each possible outcome x, what we have, these three conditions should be satisfied. Understand the concept. First is if we have a order pair, element and its probability, and that order pairs will follow these three properties, then we called it is a probability mass function. You see, I'll relate this thing with you and relate this thing to you now. See, here it is saying discrete random variable, yes or no. So that means this will be, I don't know why it is not working. Okay, this will work. Okay, this will be like this. Okay, because here discrete sample space. So in discrete sample space, if you are taking this order pair, okay, and satisfying with this property, first property is probability should be positive, okay, greater than or equal to 0, either 0 or positive. And if you add all these probabilities, f is here is probability, okay, probability of x. So if like one head, okay, then probability what I had told, outcome 2 by 4, that is 0.5, yes or no. Second type of is what? 2 head. So 2 head is 1 by 4. I write 1 by 4, so 0.25. Okay. Then third is no head. So here also one chance because 2 tail means one chance. So 0.525. You see, if we add these three value, it will give 1 or not. So this is the property. So if you add all the probabilities, it should be 1. Then next thing is that probability for this random variable p of x equal to f of x. If these three conditions satisfy, then it is called probability mass function. You see, discrete term is there, that's why mass term is coming. When continuous is there, then that time density will come. You see here, the cumulative distribution function or sometimes it is called CDF. Capital F of x we are writing of a discrete random variable x with probability distribution f of x is this. Okay, so when discrete random variable is there, okay, then we have cumulative distribution function. Cumulative means just see, first we got, you will got 0.25, second we can got 0.5, third we can got 0.25. How we write cumulative frequency? Similarly we will write. So if this is let it be a, and the cumulative will be what? First will be 0.25, second will be this two will add, so 0.75, then third will be this two will add, so it will be 1. Okay, so this is the thing. This is your called cumulative. Okay, so this is your cumulative, and this is the previous one what we had, that is mass function. Okay, now the function f of x is probability density function. Density is coming, probability density function PDF for the continuous random variable x. Here continuous is important. Continuous, that's why it is density. So continuous random variable, we have probability density function, and that will satisfy this. Probability will be positive. You see, first one is correct for that and this. But here, second one is that as we are handling with intervals, so here the integration will be 1. Their probability summation is 1 because discrete. You can count 1, 2, 3, 4. But here you cannot count that. It is infinite. Okay, number of possibilities. So in this case, you have to find out this integration from negative infinity to positive infinity. And that integration value will be 1. Or similarly, you can see this is the case. Okay. This is the area. So definite integral means what? Area. So area will be 1 unit. Understand? Third one is that probability of A less than X less than B. As we are saying line segment, okay. Just I'm drawing one pic. So let it be A and let it be B. Okay, so if I want to see this in between, okay, so that means you have to find out the probability between A to B. So this will be nothing but your integration of f of x from A to B. Or just see, if I draw this dotted line and this area enclosed this region, so this will give you the probability of this A less than X less than B. Now see, same if I do this something, you can write A, B. Okay. Now if I find probability of A less than X, okay, that means, okay, this, okay, this region, I think okay, clear? So tell me now, if greater than p x less than b, how to find? So similarly you can draw this, let it be b. Okay. So this region, okay, so that way you have to do. I think you understood this one. Next concept, so its cumulative distribution is what? This way we have to find out. Cumulative, there we are adding, here we are what to do, taking in integration, so that's why minus infinity to x we are taking, because probability of capital X less than equal to small x. This is a number. So minus infinity to x, we are finding the integration of that. Huh? Okay, so see the thing, then so let x be a random variable with probability distribution f of x. Okay, the mean or expected value of x is mu, is e of x, that is what, how to write, x into f of x. So summation of that, like one head, so 1 into what is the probability, 2 head, 2 into what is the probability, 0 head, 0 into what is the probability. Understand? So always keep in that mind that tossing of two coin problem, that will give you clear idea. That is very basic problem. Okay, so that is called expectation. If you multiply that element with the probability and take sum of all those, you will get the mu value or expected value, or it is called mean for discrete. But continuous, you have to do integrations. Simple, x into f of x dx from negative infinity to minus infinity to plus infinity. Clear? So we have a question, a lot containing 7 components is sampled by a quality inspector. 7 component, okay. The lot contains 4 good component, 3 defective components. Okay, a sample of 3 is taken by the inspector. Find the expected value, or find the expected value of the number of good components in this sample. Understand the problem? Now how to solve? Let us see. So if we write x, the number of good component in the sample, then the probability distribution of f of probability distribution of x is what? You are taking see, good component. How many components are there? There are 7 components. 4 good and 3 defective. So we are concentrating on good only. A sample of 3 is taken by the inspector. So 3 things he has taken. So in 3 things, what can happen? How many good are there? Either 3 good are there, or 3 good, so 2 good, 1 bad, mean defective, or 1 good, 2 defective, or all defective. Okay, so that how to write that function then? So that function f, if you know the basic probability, so selecting 3 out of 7 will be what? Sorry. So 4cx combination, 4cx into 3 minus x, means if you have 1 good, so it will be 4, from 4 good to 1 good you have to choose, and 3 bad to means 3 bad to 2 defective, or 3 defective to 2 defective will choose, divided by 7 c3, means out of 7 3 you are selecting. So for x equal to 1, x equal to 2, x equal to 3. So 3 things you can find, those are probabilities. So if you put 0, x equal to 0 means 0 good item, okay, whatever it is there, means all are defective. Then it will be, if you put x here, you will solve, it will be 1 by 5. So 1 by, 35. 1 by 35 will be the probability you will get. So if you put 1, then 12 by 35, 2, 18 by 35, 3, 4 by 35. Now how to find out expectation or mean? Simple. Mean means if you take all those combination, what will be mean chance of good coming? Good component. So this is 1.7. We are getting 1.1. How? So mu equal to E expectation of x. That is 0 into 1 by 35. 0 into f of 0. 1 into f of 1. 2 into f of 2. 3 into f of 3. So if you solve 12 by 7, so 1.7. So 1.7 item you will get good. So you can approximately tell. So that inspector, if he will choose and those things, at least 2 will be good component you can get in an average. So average you can say. Clear? So that way one continuous also is there. So in the next class we will discuss this continuous case when your distribution is continuous. In that case, how to find out the expectation. So those things we are going to see in the next class. Then we will see different type of models, means distributions. Okay.